What's up guys, it's me Sir Ernest, and today we're going to solve problem 7.10 of Fowles and Cassiday. The problem reads, a moving particle of mass m1 collides elastically with a target particle of mass m2, which is initially at rest. If the collision is head-on, show that the incident particle loses a fraction 4 mu over m of its original kinetic energy, where mu is the reduced mass and m is the sum of m1 and m2. Okay, so let's try to illustrate that problem first. So if this is the first particle m1 and this is the second particle m2, the velocity of m1 is v1 and the velocity of m2 is 0, which is your v2, because m2 is at rest. And then after collision, the particle moves m1, m2 with later speeds u1 and u2. So therefore, kinetic conservation of linear momentum tells us that m1 v1 would be equal to m1 u1 plus m2 u2, or u1 will now be equal to, in terms of v1, would be v1 minus m2 over m1 u2. Okay, so this is conservation of momentum. Now, because the collision happens elastically, so that means the energy loss is 0. So therefore, kinetic energy is conserved. Okay, so following that conservation of kinetic energy, we now have kinetic energy before collision would be 1/2 m1 v1 squared. So remember that the first particle is the only one that has kinetic energy because the second particle is at rest before collision. And this is equal to 1/2 m1 u1 squared plus 1/2 m2 u2 squared. Okay, so this can be calculated as follows. So following this relationship, we now have 1/2 m1 v1 minus m2 over m1 u2 squared. So this should be squared outside because this is v1 u1 plus 1/2 m2 u2 squared, and this is equal to 1/2 m1, and then we expand the square, v1 squared minus 2 m2 over m1 v1 u2 plus m2 squared over m1 squared u2 squared plus 1/2 m2 u2 squared. Okay, so this is 1/2 m1 v1 squared. So from here we can cancel these two terms, this term and this term. So we end up with a simpler example or simpler equation, that is 0 equals distributing this to the rest of the term. So this is negative m2 v1 u2 plus m2 squared over 2 m1 u2 squared plus 1/2 m2 u2 squared. So again, we can simplify this further by cancelling m2 because these are all common factors, as well as u2. Okay, so we can further simplify this, and then we end up with this expression v1 would be equal to 1/2 m1 plus m2 over m1 times u2, or u2 is equal to 2m1 over m1 plus m2 v1. Okay, now to calculate the loss of kinetic energy, so that means we have to calculate the kinetic energy before minus the kinetic energy after, and this is transferred to the kinetic energy of the other particle. So this is the kinetic energy, a loss of kinetic energy of the incident particle. So let's call that T1 minus T1 prime, and this is transferred to the kinetic energy of the second particle after collision. So this means this becomes 1/2 m1 v1 squared minus 1/2 m1 u1 squared. This is equal to 1/2 m2 u2 squared. Okay, so substituting u2 here, this side becomes 1/2 m2 times 2 m1 over m1 plus m2 squared v1 squared, which simplifies to 2 m1 m2 or m1 squared m2 divided by m1 plus m2 squared times v1 squared. Okay, so calculating T1 minus T1 prime divided by T1 will be equal to this term divided by this term. Okay, so this is 2 m1 squared m2 over m1 plus m2 v1 squared, and this is squared, divided by 1/2 m1 v1 squared. Okay, canceling some stuff here, we end up with 4 m1 m2 over m1 plus m2 divided by 1 over m1 plus m2, which is equal to our desired outcome. So this is 4, this is mu, this is the reduced mass mu, and this is m. So that's 4 mu over m. Okay, that's it. Very simple, right? So this is the solution to 7.10 of Fowles and Cassiday 7th edition. Thank you guys for watching. I hope you learned something today, and I'll see you guys in the next video. Bye bye.